We are almost done. We have 4 problems left. Okay, I know you're exhausted, but it's 10 after 11 and I am too, so we can get through this together. All right. What we're going to do on these 3 is exactly what we did on the previous problems. We're going to factor them. But then after we factor them, we have to solve them. Okay? Now, again, we're not giving you any problems that you have to do bottoms up. So these are the easier factoring problems. They all need to be set equal to 0. So we need to replace the y with a 0. Now, I'm not going to rewrite it again. I'm just going to put a 0 there. Okay? Now it's equal to 0. We are looking for factors of 35. We want them to add to get 12. Go to my calculator. Y equals 35 divided by x. And we want to find the ones that equal 12. Well, these are negative numbers. You can't add 2 negative numbers and them equal a positive 12. So I need to scroll down here. And 5 and 7, when I add them together, equal 12. So there's the magic numbers. Okay, 5 times 7. So this is just x plus 5 and x plus 7. Now, on the problems before, we were done because we were just supposed to factor. Here, we're supposed to solve. We're supposed to find the roots. Okay, so remember, the roots are the opposite. It's what's making each factor 0. So what plus 5 equals 0, and that's negative 5. That's the opposite. And then what plus 7 equals 0, and that's negative 7. So the easiest thing is just the opposite of those. Okay, if you need to, you can go to y equals, type in your equation, x squared plus 12x plus 35. Now this is just to check your answer. You cannot just do it this way because it says to factor, so you have to show how you factored it. And if you'll look, it crosses here at negative 7 and right here at 5. So we've checked it, we know that's right. 36, it does not equal 0. So what do you need to do to 9 to make it equal 0? You need to subtract 9. So this side is 0. Well, that's an x squared and that's a 9. You can't subtract those. So it's 4x squared minus 9. It's 2 terms. It's a perfect square minus a perfect square. So we do our 2 sets of parentheses. The square root of 4 is 2. So that's 2x and 2x. And then the square root of 9 is 3. So plus 3 and minus 3. Now, if you'll remember from before, we said that you can take this, set it equal to 0, and solve. Or the easier way to do it is to move the 2 back down. Move the 2 back down. And then you can just look and take the opposite of this. So the opposite of this one is negative 3/2, and the opposite of this one is positive 3/2. So there's your solution. Again, you can go to your y equals, and I can do 4x squared minus 9. Hit graph. And negative 3/2 and 3/2 is negative 1.5 and 1.5. So there's negative 1.5, there's 1.5. All right, and then 37, it's 2 terms. It's not a perfect square minus a perfect square. It's a GCF. So you have a trinomial, difference of 2 squares, GCF. So what do they have in common? 3 goes into both, and they both have an x. So 3x, take that out. And if you need to think about it when you divide it and give us enough room. If you divide those, that leaves me with just an x, and then over here is just a 5. Okay, so they get them out of my way. All right, so now we just set these equal to 0. Okay, so 3x equals 0, divide by 3, because you can divide by 3, and 0 divided by any number is 0. And then this is just going to be the opposite. Now, I'll go ahead and just solve it. That has to equal 0, so when you subtract, x equals negative 5. That's what you're doing when you're taking the opposite. Okay? All right, we'll just keep going. 38, last one. The easiest problem on the test. Where's the graph across the x-axis at? Here's your graph. Here's your x-axis. It crosses right here and right here. What are those values? -1, -2, and 1, 2, 3, 4, 5. So we're looking for -2 and 5. There it is. C. Good luck. If you have questions, ask your teacher.